A very good morning to one and all present here. I welcome you all for the second day faculty development program on trust areas of research in civil engineering. On behalf of Department of Civil Engineering, I welcome today's speaker, Dr. B. Soundra Ma'am, Professor, Department of Civil Engineering, Banariamman Institute of Technology, Satyamangalam. It gives me a great pleasure to introduce the guest, Dr. Soundra Balu, as a professor in the Department of Civil Engineering, Banariamman Institute of Technology, Tamil Nadu. She has obtained BE in Civil Engineering from Alahappa Chettiar College of Engineering and Technology, Karaikudi, Tamil Nadu in 2002. Masters in Soil Mechanics and Foundation Engineering from College of Engineering, Guindy, Anna University in 2004 and PhD in Geotechnical Engineering from Indian Institute of Technology, Madras in 2010. After working for about 2 years in UAE, she has joined as assistant professor and head at SKR Engineering College, Chennai, and then joined Banariamman Institute of Technology in 2015. Her research interests include study on the behavior of problematic soils, various ground improvement methods, and physical modeling of geostructures. She has received grants from various government funding agencies like AICTE, DST, NIMAT, SERB, and TNSCST, and recipient of the Early Career Research Award from the Science and Engineering Research Board in 2016. She has published around 25 peer-reviewed journals, 31 conference papers, 3 book chapters, and filed 3 patents. She is an active member in 5 leading journals, chaired technical sessions in 3 international conferences, organized and attended more than 25 skill development programs, and also delivered about 25 guest lectures. She has guided 2 PhD scholars and currently guiding 8 members. She is a professional member of American Society of Civil Engineers, International Society for Soil Mechanics and Geotechnical Engineering, Indian Geotechnical Society, and Indian Society for Technical Education. Ma'am, we are very happy to have you with us. Once again, I welcome you for this faculty development program. Kindly take over the session, ma'am.
Yeah, thank you so much, Ms. Shobana, for giving me this opportunity for sharing my view among this great audience. First of all, I would like to congratulate the organizers for getting this much participants for FDP program in this pandemic situation also. So hope all of you are safe in this situation. So I will just share my views about the ground improvement techniques and few things I have studied from the literature. That also I will show you. So there are so many research avenues in geotechnical engineering. One of the major avenue is ground improvement techniques. So I'll share my PPT now. So hope it's visible, right?
Yes, ma'am.
Okay, thanks. So today I will talk about some of the aspects which related to the sustainable ground improvement techniques. Of course, the ground improvement techniques itself or the sustainable solutions for any ground problems. Anyway, in that itself, we can utilize some of the waste materials as one of the ingredients in the ground improvement techniques. So that part I will just concentrate, and more of the research in the ground improvement techniques nowadays are related to the waste utilization. So that may be a part of research in any of your firm. So that's why I have chosen this topic, which is related to some of the research focus. You can take it forward. And this is my presentation outline. Why, what is sustainability? Why it is being told by nowadays? It's a crazy word, right? For everything we are using this sustainability term nowadays. So why it is so much popular in these days? So that part just I will touch up, and sustainability approaches, especially in the ground improvement techniques, and a few research works and case studies. Few of them I have also tried in my laboratory, in our laboratory, and also I have taken the other research works that are carried out in and around the world. So the origin of sustainability idea, it came from the origin from 1970s. So it is so become popular in Western area when the environmentalism became one of the major issue. So the key triggers of the idea, mainly the degradation of Earth's life supporting capacity, and also we need to get awareness about the environmental problems. Because of industrialization, most of the environment degradation has been happened during this 19th century. So the origin of sustainability idea, though it is become the practice of our olden days also, but the emphasis for being a sustainable concept in every aspect of our research or every day-to-day life will become the major thing only in the 19th century. So it gives a major impact for the current generation decision making also. So mainly the definition of sustainability given by UN United Nation, our common future report that gives in 1987, which is sustainability is the development that meets the need of the present without compromising the ability of future generations to meet their needs. So it is nothing but we have to utilize the resources. In the same time, we have to keep the resources for our next or future generation. So that is the concept of sustainability. And also we have AAC definition, which is nothing but it is a triple bottom line. We have to concentrate all the things which are lying under the umbrella of environment, economic, and society. So all these things we have to take care and without degrading any quantity, quality, and availability of natural, economic, and social resources, we have to make a path. So that is the major definition which is given by AACE. So we have different avenues here: the environment, economy, engineering, and equity. So it is stated by Basu et al. So they have given so many conflicts to achieve this kind of sustainable aspects among all the E's, 4 E's. So this is 4E concept. There are so many 4E's, 5E's, different avenues given by different authors. So I will not go in detail about that. Anyway, this is the 2030 agenda for sustainable development. So sustainable development goals. There are 17 goals associated, 169 targets. For each and every goal, there are some targets. If we have achieved the targets, then we can achieve the goals. So like that, UN has given these targets. In this, we have so many targets like no poverty, zero hunger, like that. So our responsibility as a civil engineer, we have these things like industry, innovation, and infrastructure, sustainable cities and communities. Especially, I think these two, and also some of the things which we can concentrate on: clean water and sanitation. So all these are comes under our umbrella. We need to take forward about these goals, and we have to achieve the targets given by these goals. So in order to make a sustainable environment, as a civil engineer and as a geotechnical engineer, we normally go for ground improvement techniques. So why we need to go for ground improvement techniques? First of all, as a civil engineer, we have so many diverse and important encounters with soils. So we use soil as a foundation element. So we can lay the foundations on the soil so that the soil can take away the load. So we need to we need to depend upon the soil for its bearing capacity, and also we have to monitor the settlement at the same time. So first of all, we use the soil as a bearing medium, first case. And also we use the soil as a construction materials. Maybe it is a fine graded soil or a coarse grained or a even gravel, boulders. We can use it as a construction material. We need to rely upon its properties. And we have to take care about the lateral pressure given by the soil in most of the excavation, underground tunnelings or openings. We need to take care about the lateral pressure which is offered by the soil, because it can easily lay down to its own angle of internal friction or angle of repose. So if we want to retain the soil, it will exert some pressure. So that we need to take care. And in our day-to-day life, we are encountering so many soils, right? So because of the different deposition processes and also different weathering conditions, we may encounter different types of soils which are not at all suitable for our purpose. So as a civil engineering point of view, we have some boundaries within which we need the soil to behave. But normally in practice, the soil won't behave what the way we want. So normally we want the soil to be possessing a high bearing capacity, low settlement values. So all these things we want from the soil, and without any so many fluctuations with the moisture conditions. But the soil in nature will have difference in their medium. So I will just touch upon what are all the problematic soils. So problematic in the sense in which way it won't react and in what way we want. So those are called the problematic soils. So the collapsible soils, which has a metastructure, capillary metastructure. In its structure, if any water enters, then the capillary structure may collapse. So in turn, sudden reduction in the volume leads. So which will leads to the sudden collapse. So it is not at all recommended for any structures founded over this kind of a soil, right? So we can identify this soil by measuring its void ratio. So the difference in the void ratio between the dry state and watering state, and its natural void ratio. All these things we can put together and get a term called a collapse potential. So depending upon its percentage, you can mention about its severity of the problem. So 0 to 1 means it's okay, it's problematic. But if it is more than 5, then it is a troublesome soil. So we need to do some ground improvement techniques in order to carry over some of the construction activities over those soils. So this is the sudden subsidence and collapse, which may be around a few meters surrounding. So all the structures which are laid over the soil may get collapsed due to this sudden collapse. And the other type of soil, liquefiable, it's not a type of soil, it's a condition actually. So during a vibration or a dynamic load, especially during earthquake loads, what may happen if a sandy soil is below the ground level, and if there is a water level here, and here the soil, if it is a loose sandy deposit, then what will happen? Immediately after a sudden vibration, the pore water pressure tends to build up. So we know the water which is inside the pores may call it as a pore water. So when a sudden vibration occurs, then pore water pressure will build up, and a sudden build-up of pore water pressure will cause the effective stress will become 0. When this pore water pressure equals sigma, then effective stress becomes 0. So effective stress is normally useful while getting the shear strength of the soil. Normally this is the shear strength of the soil by Moore-Coulomb equation. So if it is effective stress condition, tau is C dash plus sigma dash tan phi, right? So sigma dash is 0 means what will happen if it is a yes. Okay, there is some disturbance. Anyway, this for cohesionless soil, this C will be 0, right? So tau is equal to sigma dash also 0. So the shear strength will become 0. Once the shear strength of the soil becomes 0, it may float, right? It may just lose its bearing capacity. So whatever the load which is over the soil may collapse. just tilt it over. So it is a kind of a liquid behavior, and this will normally found in the cases of cohesion-less soil, loose cohesion-less soil below groundwater table. So it's a kind of a piping failure. It's after Kobe earthquake, liquefied soil and the collapsed buildings. So mainly the sand classification, especially for the based on the relative density. So the relative density has correlation with SPT N value. SPT is standard penetration test N value. So normally we do SPT test for any soil exploration purpose. So based on those values, we can classify the sand deposits. So when up to a SPT value of 0 to 5 or within 10, the soil behave as a loose sand deposit. So if this sand lies in the earthquake prone zone areas, then definitely if it is lying below water table, there will be a liquefaction. So we need to treat this kind of a soil, or we need to increase the density of the soil by introducing some of the ground improvement techniques. Then these are the contaminated soil. Contaminated soil in the sense it is normally contaminated with the biodegradable or non-biodegradable material. Usually it is very difficult to understand the behavior of this kind of a soil with time. So if we perform the consolidation test for a soft clay, even if we perform 1 year later also, the soft clay will give the same details about the coefficient of consolidation, compression index, everything. But if you perform a consolidation test, a simple consolidation test for the contaminated soil, it won't give the same result after a year or two, because it is already getting decayed because of the biodegradable material in it. So it is very difficult to predict the behavior of this kind of soil. So that is one of the major problem in these kind of soils. And another one is expansive soils. So expansive soils are nothing but the soils which can easily swell and shrink. Swelling means increase in volume, shrinkage, decrease in volume upon changing moisture conditions. So normally we encounter different seasons. So with the different seasonal variations, the swelling and shrinkage might occur, and it will reflect on the behavior of the structures. Normally this is this type of clays or having a type of mineral called montmorillonite, which has the ability to swell upon increasing its water content. So because of that, the lightly loaded structures which are founded over this kind of soil will uh, severely affected. Why? Because lightly loaded structure, because the uplift pressure which is given by the soil has to be bared by the whatever superstructural load. But if it is a lightly loaded structure, then this uplift pressure might cause uplift on the lightly loaded structure and cause differential settlements. So normally the identification pattern has very basic test parameters like Lucke limit, plastic limit, and shrinkage limit. So with that we can get the plasticity index and shrinkage limit, which is very important parameter for expansive soil. So with the range, with this range, we have the swelling potential as a very high swelling potential soil. So when the plasticity index is greater than 35 and shrinkage limit less than 10 or so. So again, the same thing. This is a lightly loaded structure. This is, I think, this picture has been taken in Chennai, near Anna Nagar area. So most of the buildings in 1980s have been collapsed by these kind of expansive soil in Anna Nagar area, especially the G+1 buildings. I think my net is over. Net connection is better. Anything is there? Please tell me. Is that okay?
Excuse me, ma'am.
Yes, sir.
There is one menu is there at the bottom of that in blue color. You can press that hide button so you can see the images clear, or tabular columns in the
Yeah.
bottom portion of
Oh,
the slide. Okay, thank you, thank you.
okay, sir. Thank you. Okay. Then another type of soil is normal soft clay soil deposits. So we all know that soft clays will possess a very low bearing capacity, and it has a capacity of very high settlement. So both of these two aspects are not wanted by the geotechnical engineers. So it is comes under the normally the problematic soil. So usually we identify the clay deposits, clay soil using the undrained shear strength. For the soft clay deposits, we can perform the vein shear test, and for somewhat firm to stiff, we can go for UCC or any other shear testing methods. So based on the undrained shear strength value, we can classify the consistency of the clays as soft to very soft. So we need to do some better improvement for this kind of soil by introducing some ground improvement techniques. And another type of a soil called a sensitive soil. So if they are in the undisturbed state, they can hold this much load. But if you just disturb its structure, then by remolding, then it may flow as a liquid, right? So this is because of the cardhouse structure of this kind of sensitive soils. So normally the sensitive soils can or appear to be very strong, but a slight disturbance make them weaker. So it is a lead clay, usually found in Canada. This sensitivity value normally can be calculated by using the vein shear test. So sensitivity, that is without any disturbance, what is the undrained shear strength, and with remolding, what is the undrained shear strength. So if you get a ratio of it, then that is called a sensitivity. So if the sensitivity is greater than 8, then it is very very sensitive. Actually, it is very sensitive. So after that, this is actually very slightly sensitive, medium sensitive, very sensitive, and after that slightly quick. Even it can act as a quicksand condition, like liquefaction. It can act as a quicksand condition. So this is about the sensitivity of the clays. So there are some special problems like piping failure because of sudden rainfall conditions. It may cause some piping failure. This is a recent landslide in Munnar. So there are so many reasons why we need to go for any ground improvement technique before going for any construction activities. So the ground improvement techniques also, we need to optimize it. So how we can optimize the entire solution regarding the ground? The first thing is about, we should have a very good data about the soil. So what kind of a soil deposit is there? So that can be get only by doing the extensive soil investigation. So we may require for extensive soil investigation around 2% of the entire project cost, but most of the situations we neglect this kind of a soil investigation, right? So that should be avoided. So we must have a very good soil data, then only we can think about the improvement methods to be adapted for the soil. And physics, so what kind of force which is acting? If it is a cohesive soil, cohesive force will be there. Cohesionless soil, friction will be there. So what is the physics which control the entire mechanism in the soil? That we need to assess. Then materials, so that part I will go in detail in this presentation. So the materials which we are using for the construction or any treatment methods, so that should be cost effective, and the carbon footprint of the material should be low, and it's a kind of waste material. If you reuse, then it will give further optimization to the problem. So that we need to take care. And time, how long do you take to process the whole thing? And convenience, whether the solution we are giving is a flexible, and we can, if we allow the changes in between. So those things we need to think about before getting a suitable technique like ground improvement techniques. So these are the approaches we need to get before any optimization of the geotechnical project. If you go for any ground improvement techniques, we can classify into ground improvement, ground treatment, and ground reinforcement. There is a very slight variations in these terminologies. Ground improvement means the ground is same, we will not include any material into it, but we will improve the ground by means of some densification techniques, or we can use some hydraulic techniques to reduce the water table, or reduce the pore water pressure in it. So like that, if you improve the condition of the ground by mechanical means, normally that is called a ground improvement. Ground treatment means we need to treat the ground by giving some dosages. So normally, if you go to a doctor, he will give some medicines to treat us, right? So similarly for soil also, we need to give some additional material to treat its behavior. So whatever we need, we have to implement in it. So by introducing like a cement or any admixtures like lime or fly ash, we need to add that one and treat the soil in what way we want. And reinforcement will also perform like a treatment, but it will not react with the soil, but it will induce some friction, additional friction to the soil, so that the reinforcement can have the additional benefit of the shear strength. So all these are different mechanisms, but the aim of that, the entire thing is to make the soil behave what we want, in what manner we want. So in the ground improvement technique, we can adopt some sustainable consideration. We can have sustainable materials like recycled or waste materials like fly ash, bottom ash, shredders, cutters, glass, quarry fines, blast furnace slag, and etc. etc. A lot of research is going on this avenue. Reuse, use, recycle the waste materials, especially from the industrial waste. And bioengineered materials, geosynthetics are called sustainable material, especially used in the ground improvement techniques. Yes. Yes. Okay. Okay. Next one is sustainable energies. So we can use the geothermal energy. There are very slight research is there in this area in as far as India is concerned, but in foreign countries they are using this geothermal energy for even for by using the pile foundation. Also uh, they have trapped this geothermal energy using the within the pile foundation, and that geothermal energy can be utilized for their energy purpose. So like that, there are some energy technologies which are related to the foundation engineering. And the sustainable system, normally what systems we are having as a ground improvement techniques, all or comes under the sustainable system. So most of my lecture today will focus on this sustainable materials. So I'll just give a glance about some of the research works and case studies available in this sustainable materials. So the first thing is the geosynthetics. Geosynthetics nowadays have been used for each and every project by somehow. So in most of the projects, we are using this kind of a geosynthetic material. Most of the geosynthetics are made up of FDP, high density polyethylene material. These are normally, there are different varieties in it: geotextiles, geogrids, geocells, geomembranes, and this is actually Zytrack. It depends on the purpose where we are using. So based on the purpose, different varieties of geosynthetic materials are nowadays coming up. And normally we are also depending upon the geosynthetics very much nowadays. So especially these are the major functions of geosynthetics. One is the separation function, especially in the road pavements, to separate the soft subgrade and the subbase material. So that is the separation function. Filtration, especially for the water filtration, and reinforcement. So this is a major thing we expect. Normally we use a geogrid and a geotextile as a reinforcement material, and slope protection. For all these things we are using the geosynthetic materials. So these are normal traditional solutions in before 1980s. These are the normal traditional solutions what we follow. But nowadays we are going for geosynthetic solutions. So normally we in olden days we go for wide footings to reduce the foundation pressure. But nowadays we are going for reinforced soil beds so that we can reduce the size of the footing with multiple layers of geosynthetic layers. Then the consolidation process. So the consolidation can be easily performed, or the rate of consolidation can be easily given, accelerated by means of drains, sand drains. But nowadays we are going for PVDs, prefabricated vertical drains, so which has a core material of geosynthetic material. And granular columns to improve the ground. Nowadays we are going for encased granular column, so improve the performance of the granular column by encasing it using a geosynthetic material. And use of shallow slopes with the berms and steep reinforced soil slopes. Even I will show you a case study. Even in that case study, a steep reinforced soil slope of about 70 meters have been built. So it is a very novel solution for any steep reinforcements, steep retaining structures. And gravity retaining walls, and nowadays reinforced soil, flexible retaining walls. So all these have come only because of the novel invent of geosynthetics. So geosynthetics are a better sustainable solution in view of any ground improvement technique. And if you talk about the fill materials, for earthen fill materials may need for any embankment purpose or any fill material embankment for any railway. Yes. Okay. So that fill material can be of industrial waste material. So we have this is these materials which we have focused for geocell fill. So geocell, I have shown you that it's a three-dimensional structure. So within this we need to fill. Okay, we need to fill some portion of the soil or any fill material we need to have in order to increase its performance. So that can be given by means of this kind of industrial waste. So there is a review paper done by us. So it states these are the possible fill materials which can be taken from the industrial waste, like a fly ash, waste foundry sand, wrap material, reclaimed asphalt pavement, recycled construction and demolition waste, crushed concrete waste, slag from any steel industries, and mine waste. So all these waste can be used as effective fill material for not only for the geocell, for any case where we need to fill the soil with the soil or any embankment purpose. We can go for this kind of waste material as a fill material. And this study was performed by Luhua. So they have used the tire chips as a fill material in geocell for the foundation reinforcement. So they have introduced geocell as a reinforcement material, and for that geocell they have used tire chip fill as a fill material. So tire chips are the waste materials which bought from the tire factory, or the waste tires, we can make it as a chips. They have used that with a part of sand sand. So by weight of sand, they have used around 8%, 10%, and 12% of chips content. So by varying a different percentage, they found that the better performance was achieved by 8% of tire chips, and the maximum value of bearing capacity ratio also achieved for 8% tire chip content. So they have adapted the optimum as 8% with optimum number of reinforcement layer as 2. So they have also changed the number of layers. So with the different number of layers of geocell, 1, 2, this is unreinforced, 1, 2, and 3, and 4, they found that the optimum performance was for the 2 layers. 2 layers of a geocell material, and the fill material of 8% tire chips by weight of sand will be an optimum solution. So it is coming in the air, it's been published in ACE. So like this, we can do some research over the fill material for by using any industrial waste. And this is a full scale nest environment using lightweight geomaterial. So the reinforcement has been done by means of a geogrid, and the fill has been filled with the rubber layer chip and sand mixture. And they have used the segmental concrete block as a facing, and also they have used gabion boxes for the sloping sides. And they have also studied using the Flax's 2D about the behavior of this reinforced wall. So this is what we have made the full-scale embankment. This full-scale embankment has been instrumented properly with the earth pressure cell in kilometers. So in kilometer for getting different settlement profile, and subsurface settlement plate was there, and piezometer to study about the pore water pressure distribution, and strain gauges, and extensometer. All these are well instrumented, and they have observed the settlement pattern and pore water pressure development by constructing this kind of full scale embankment. So and also analyzed the plaxis. Actually they have analyzed for undrained case. So these are the observations they have made. The computed lateral wall movement over predicted the measurements. This may be due to the negligence of drainage conditions in the Plaxis 2D software. So they have not modeled properly the drainage conditions. So that may be the reason for the over prediction of lateral wall movements. And the simulated geogrid movements under predicted the observed field data. And there are some deviations with the predicted and observed field and a Plaxis report. Anyway, they have made some comparison and given their solutions how we can improvise the modeling part. So like this, we can give some solutions with regard to the modeling part, so that if you since in our cases as of private engineering college or low level research institutions, we cannot perform like this a full scale embankment modeling, right? So in that case, if you have a very well defined Plaxis or any not only Plaxis, any software finite element model which can perform better or which can easily correlate with the case of full scale embankment or whatever the large scale model reflects, that will give very better research findings for us. So we need to have much more focus on this kind of research. And in some cases, they have used C&D waste, construction demolition waste material, as a fill material. Here also I have given the geocell, and the fill is C&D waste. And they perform some cyclic test and arrived the conclusion that geocell reinforcement could improve the cyclic ratio. So they have the cyclic response is very good, improved by the introduction of CND material. So it is published in Transportation Geotechnics. And Castanevo, they have valorized the fine-grained CND waste. Normally, we concentrate on coarse-grained CND waste, but they have adapted also the fine-grained CND waste in the reinforced soil structures, and they have tapped that solution for RSS. Again, they have made some real model for this kind of embankment with geogrid material as a reinforcement and CND waste as a fill material. They have monitored for about 1 year, and they have examined the geosynthetic specimens, and they found that there is no damage to the geosynthetics, and it is well performing after a year also. So the major findings, they have performed the laboratory leaching test, especially for CND recycled material. Leaching could be a problem, but they found that based on the laboratory leaching test, CND materials are can be classified as a inert material. So we can use this material as a fill material for geocell or any fillings. And CND recycled material exhibits suitable shear strength and can be used as a construction of geosynthetic reinforced structures. And they have adapted 2 geogrids and see the performance after 12 months. So they did not found any damages to the geogrid or any degradation. Then this is a study which is done in one of the Indian laboratory, I think in IIT, some of IIT. So it is using the geocell reinforced coal mine overburden waste. So they have used the coal mine overburden waste as a subballast in railway tracks on weak subgrade. And they found that we can use this kind of waste material in order to improve the performance of the subballast layer. And this is one another field test, which I think this is performed in some of the foreign countries. So this is the reference which is taken from AIS. So they have used, they have monitored the geocell reinforced RAP basis. So RAP is reclaimed asphalt pavement. So asphalt pavement, after its lifetime, we are just removing it and we are applying the second layer or the fresh layer. But we can utilize this already reclaimed asphalt pavement as a base material for flexible pavements. So they have made this study and even in the expansive soils. So they found that the 100% RAP replacement is not feasible, but we can we can use some of the maybe 50% RAP for the base layer. But they told that 100% that can be used in the base layer is no significant. If we use the geocell reinforcement, then we can utilize 100% RAP. That is the finding given by them. They have also monitored with the different monitoring earth pressure cells, settlement gauges, and all these things they have performed and monitored the subgrade and the geotextile layer and found that it is performing very well under the geocell reinforcement with 100% RAP. So they have monitored for about 1 year. Then this is one of the study, I think this is in IIT, some of the IIT. So they have used the fly ash as a material, fly ash as a bed material, and utilize the geocell as a reinforcement. So why I am talking so many things about geocell, I have made a review on geocell. So what are all the different waste materials they have used for a geocell fill? And also one of my PhD scholar is doing work on the geocell fill material, different fill material, especially the industrial waste material. So it is a kind of research we can do, And before that research, we need to analyze the entire studies which are available in that area. So for that sense, I have made all these reviews. So I'm just presenting these papers to you so that you can get an idea about what are all the research which are going in premier institutes like IITs and other foreign universities. So here they have adapted the fly ash bed and geocell mattress with a basal geogrid and jute geotextile separator. So they have made a footing, they have just modeled a loading plate as a footing, and uh, monitored the settlement. And load settlement behavior is given here. And they found that there is no surface deformation occurred during the footing settlement in reinforced fly ash beds. So that is one of the better observation they got. And not only in a laboratory scale, in India also we are practicing it in the field applications. The copper slag, this is the bridge approach embankment constructed with the copper slag, and this is the road which is made with the waste plastic. And this is the Nizamuddin bridge approach in New Delhi, which is constructed using fly ash, completely fly ash. This embankment, road embankment, was constructed completely using the fly ash. And in some of the projects, GSY roads, we are using the jute geotextiles. So it is a natural geotextile, and for the rural roads, they can use it. And this is the plant which can segregate the CND waste materials, and from this we can easily got the CND waste for our purpose. And I want to mention about one more material called CLSM. CLSM is it's a kind of a material. So normally it's a controlled low strength material which is made up of different industrial waste. So it's a project in I think it's USA. They have adapted design and installation of long pipeline. It's about 225-kilometer pipeline. So it carries the water from different regions and distribute it to some other region. So I don't know about all these names, but it's a very long pipeline. Okay, so for that pipeline, we need to make the haunch or bedding material. So that material, what they think we can backfill using some CLSM material. So they need to excavate a portion of a soil from here, so that they have to install this pipe, and they need to backfill. So what they think, why can't we use this excavated material as one of the ingredient to CLSM, and we can make as a bedding material. So they have checked that one, and they have used the native soil as a CLSM material. So CLSM normally it has these properties. It should be flowable. CLSM should be flowable, self-leveling, and solidifies. So maybe it may not perform that much comparable with the concrete material, but for a pipeline bedding, we just have a stiff material. We need to have a very stiff material. That's enough. So they can utilize the CLSM. So CLSM, the conventional CLSM has fine aggregate and cementing agent, and maybe fly ash or any industrial waste material. But for here, they have utilized 10% cement, and most of the excavated material, they have used it for the fine aggregate. So they have added all these things and made the CLSM, and they have tried for combination of soil type which reduce the required water content by 20% and setting time by 2 hours. These are the limit they have given, and within that they have made a trial in the laboratory and found a better proportion and use it for a CLSM. So it is a field demonstrated case, and they obtain some of the sustainability consideration in this project. So what are all the major impact using this CLSM material using the in-house material. It has social impact by reusing the excavated material, and there is a less damage to city pavement due to less transportation. There is no transportation from any industry, right? They are utilizing the excavated material for their purpose. And economic impact. So there is a cost saving from the reusing native material. There is a limited landfilling cost. There is a limited transportation cost. So that is comes under the economic impact. And environmental impact, since because we are reducing the transportation, there is low carbon emission and less landfilling because the excavated soil can be reused. So all these triple bottom line that I have mentioned earlier, social, economic, and environmental, all these lies in this project. So they claim this project as one of the sustainable project, and they made the sustainability assessment also by using some software. So these are the assumptions they made: 100 feet for pipeline, so 60 miles. So these are some of the inputs we need to give for sustainability assessment in case of transportation that reflect the CO2 emissions. So they have made 3 different calculations. One using the native material without any treatment as bedding and embedment, and using imported material as a bedding and embedment, using native material with treatment with some other additive materials. So they found there is a reduction in CO2 emission both of these cases. Rather than if you import the material, we can utilize the available material for our purpose. And also the cost analysis, again for the 3 cases, they found both of them will reduce the cost much rather than importing any material from outside. So this is one of the field case study which reflect the sustainability of the project. So the lessons majorly learned from this case study: there is a considerable potential for reuse of the local native material. Even though the local native material, they have mentioned it as a CH, that is the clay of high compressible in nature, but they have utilized this native material as a CLSM. And there is a major reduction in carbon emission. There are several millions of dollars of cost savings. So for each and every project, we should look upon any point which can give this much benefit to the project. So that is nothing but the sustainable aspect of the project. Next one is this is my own project. The expanded polystyrene, so which is normally called as a thermocol. Okay, so the expanded polystyrene, normally we generally know it by the name thermocol. It is a lightweight, durable, and moisture resistance can be given. These are some of the properties of expanded polystyrene. So why I'm talking about EPS here? So I have used the EPS, not only I have, but earlier studies reported that the compressible inclusions can be given to any geotechnical applications in order to reduce the pressure given by the soil. So they have adapted, this is given in 1997 itself by Harvard. They have used the compressible inclusion in a retaining wall. This is an expansive soil. So in order to take up this expansiveness, they have included this compressible material so that it can perform as a compression material, so that it can take up the heave and also the pressure which is exerted by this expansive soil. So that is one of the purpose here. And here also this compressible inclusion can act as a cushioning material, and even above the pipe material, like a haunch material, we can utilize the compressible inclusions. So this I have applied for expansive soil. So this is the project which I got from SCRB for under early career research. What we have proposed, this is a pure laboratory study. So for the expansive soil, one of the treatment method is lime columns. So for the expansive soil, we can treat the soil by introducing the lime as a column for some deep strata treatment. But if you use lime as a material, the first thing is the cost, and the second one is environmental degradation. In some cases, the lime may increase the pH, so it may lead to the poor environmental problems. So, in order to address those problems, and EPS, which is a waste material, the EPS waste only I have used here. So, the waste EPS geofoam can be utilized in the place of lime or cement or fly ash, whatever we use for a column for improvising the expansive soil, and replace that with the waste material, and giving some inclusion to the expansive soil to take up the swelling. That is the main aim of this project. So we have designed some experimental setup and found the swelling and swell pressure of the soil in addition to the blocks or EPS columns. So these are the material properties of the soil. We have identified two types of soil with a different plasticity index and swelling characteristics. So these are the characteristics, physical properties of soil. Both the soils are CH with a reasonable swelling. So we have found that the shrinkage limit is 8 and 10 for the soil A and B. And the plasticity index, here you can tell about the plasticity index. So both are very high. Soil A is pure bentonite, so it is having a very high plasticity index and very low shrinkage limit. This soil B is a natural soil which is got from the Nanagar area of India, so it is having a reasonable plasticity index and the shrinkage limit. Both of them are highly swelling soil. And we have adapted two different geofoam. In addition to the waste EPS material, we have bought some geofoam material from the factory itself that gives these values, EPS 12 and EPS 15. 12 and 15 there is some, gives the density of the EPS. So the minimum density is around 11.6 and 14.7. So based on two different materials, we have performed the compression inclusion testings. So these are the values which are already given by the manufacturers itself. And in order to study about the recyclability of EPS beads, we have just taken the already used thermocol boards and made it into beads. That beads should pass through 2 to 6 mm. So that is the size of the beads we have used for our purpose. And this is the experimental setup which we have fabricated in our laboratory. This is a very similar to one-dimensional consolidation testing. So this is nothing but a consolidation testing equipment, but instead of using a 6 centimeter mold, here we have used 150 mm, that is 15 centimeter, which is nothing but a CBR mold. So diameter is 15 centimeter, height is around 170 mm. So in order to accommodate that CBR mold, we have just fabricate this kind of a large scale one-dimensional consolidation apparatus. So that is the only cost part which we need from the project. So they have given the cost required for fabrication of such two experimental set, two such a large one-dimensional apparatus we have made in our laboratory in order to study the free swell. So free swelling of the column can be studied by this gauge, dial gauge, and also we can include here the pressure in order to get the swell pressure. So here we can achieve up to 600 kPa. So using this we can get the swelling pressure of the soil. So in the first series one, this is published in IGJ, and in the first series one we have used the EPS as a layer. So geofoam layer we have used, and we perform tests for 10, 30 and 50 mm thickness with different densities. So these are got from the factory made. So we have just replaced the soil with 10, 30 and 50 mm thick geofoam layer. So this is how we are making the specimen. Since the height of the CBR mold is 175 mm, we just make a 100 mm thick soil sample. So this is a spacer which is used to make that soil specimen. So if you are going for a laboratory testing alone, we need to ensure that each and every aspect is already being think of, and we have during the laboratory testing we need to use this kind of precise things so that we can have representative samples for all the testings. So from the plots, these are the plots given from the test. So that this is the time versus swell plot for it's more than it's around 6 to 8 days we have monitored. So based on this, there is a reduction in the swelling. This is the soil alone, so without any placement of geofoam. So with the increase in the thickness, we can see the reduction in the swelling percentage, and also this is the swell pressure value. So after the complete swelling, we just allow the soil to have a pressure, incremental pressure. So the pressure at which the 0% movement occurred is nothing but the swell pressure. So similarly, we have performed all the loading test for all the soil sample and found the swelling pressure. And this is the observation we got. The percentage swell got reduced by 60%, and the swell pressure got reduced by 80% for the lowest density of the EPS geofoam. And in the series 2, we have adapted the column, geofoam column. So here, for the column, we have made 25, 50 and 75 mm diameter column with the two different densities, 12 and 15. A similar observation with the different, with incremental in the diameter of the column, we have found a reduction in the a very high reduction in vertical swelling, and swelling has been reduced, and 55% of swelling pressure has been reduced for lower density of EPS, that is 12 kg per meter cube. And in the series 3, we have just added the EPS beads. So here we have used the waste EPS beads in percentage to the dry weight of the soil. So we have just mixed it and performed the test. So 0.25, 0.5, 0.75 and 1% of dry weight of the soil we have mixed and performed the compaction test to obtain OMC and MDD. And on this OMC and MDD, we have performed the swelling and swell pressure tests. So we have found a reduction, higher reduction in the with the increase in the percentage of the introduction of the geo beads. And in the series 4, we have used the geo beads, waste geo beads as a column material. So if you introduce the column material for different diameter, we have shown difference. So for that, I have just given here the experimental setup. We make a column into an expansive soil. So for that, we need a guide pipe, and the compaction was done by an UTM, and this guide pipe can be removed, and it is to be filled with the geo beads. So we have done the swelling and swell pressure test for all the columns, and we found that with incremental for L by D ratios, different L by D ratios, the maximum swell is decreased up to 0.4 times when compared to soil alone. Similarly, we have adapted for another density and found a decrement in the swelling. So from that study, what we can observe, we can effectively utilize a waste material as a cushioning material for a major problem of expansive soil. So any questions so far? Am I audible?
Yes, ma'am.
Participants, if you
Okay.
have any queries, you can kindly post it in the chat box.
Okay. I just want to confirm whether am I audible.
Yes, ma'am, you
Okay.
are audible.
Okay. So the next thing is, if you have any query, you can ask. You can stop me at anywhere, and you can ask also,
Okay, ma'am.
because it's a more of a one-way talk. So you can ask if you have any queries, especially with regard to my work, because that was my work which is granted by SCRB, and we have finished it, and one PhD scholar um already finished that work. So that is one part. And MACP technique, which is also I have tried with one of our PhD scholar, and he also submitted his thesis now. So this is about the microbial induced calcite precipitation. So which uses some of the microbes, especially the bacteria, for the ground improvement purpose. So what the technique, using that technique, they can produce some calcite carbonate mineral using the MICP process, and that can be acted as a soil stabilizer. So normally we got this kind of calcite mineral from the lime or cementing material. But here we are just utilizing the natural medium like microbes, and we are getting this calcite carbonate mineral from the bacterial activity. So there are two notable mechanisms. One may be bioclogging and biocementation. Both of them will improvise the soil properties by filling the pores by using the filling materials and particle binding materials, and thereby increasing the shear strength of the soil. So these are some of the ingredients which are used in MICP. First of all, we need a catalyst to improvise the reactions. So it is called a microbe solution, and a cementing medium, and a nutrient broth, and pH stabilizers. So we use two cementing medium. One is eggshell powder, and another one is calcium salt solution. So even eggshell powder is a natural material, and we tried with this eggshell powder in order to get a comparison with the already available calcium salt solution. So we have prepared this one, and microbes. There are a number of microbes which are available with different families. We have used Sposania and Lysine bacillus bacteria. And the main role of the bacteria, it will act as a it will create an alkaline environment with high pH, so that the calcite precipitation is possible with the calcite ions. So these are the reactions we can expect in this process. So the enzyme urease produced by urease producing bacteria, hydrolysis, which can hydrolyze the urea. So this is the urea, which can be easily hydrolyzed to give an ammonia. So this ammonia can boost the pH of the soil medium and improvise the calcite precipitation, in turn which will act as a binding material and improvise the shear strength of the soil. So this is what the reaction behind the MICP process. So the major advantage is being it's a non-toxic technique. We are not utilizing any chemicals which are not environmentally friendly. So here it is not damaging the environment, and the calcite produced imparts additional fertility to the soil. So wherever it's possible, we can utilize this material for increasing the fertility of the soil. It is another venture of this kind of um, process, and it's a non-toxic thing, and hence it is eco-friendly, and it is easy to handle like a cement. So once the product is formed, you can utilize and handle that as a cement and utilize for our soil improvement purpose. And in terms of waste minimization, and it's a cost-effective technique. The research scholar has taken two types of clay soil. Normally, this kind of research work has been extensively done by either India or in foreign, especially for the sandy soils, the coarse-grained soil, which has a very high permeability. But we just tried for clay soil, and compared with the sandy soil also. Definitely the improvement will be higher for sandy soil, since the permeability is more, and hence the easy penetration of bacterial solution will be higher for sandy soil. But anyway, we have found some improvement even for clay soil with low compressible and medium compressibility. So we have adapted two types of bacteria, and two types of cementing chemicals like eggshell solution and calcium chloride solution as a calcium soap. And he has tried with the different modalities, and found that polarity gives the 0.5 glass cementing medium, especially the eggshell cementing medium, gives a better urease activity. So it is one of the observation what we have observed. And also using FGC test for different cooling periods, we found that the strength is improving. Not like sandy soil, but it is improving clay soil also. There is a much research gap available here for the clay soil to adapt this technique. So it is one of the research avenue. And finally, I just wanted to give this airport project. This is actually borrowed from a ferry presentation. So I love this project scope, since they have utilized, they have our own firm. So they have their own R&D cell. In that, they have modified all the geosynthetic products in order to get a field-oriented products, so that we can utilize that for the site-specific conditions. So in that aspect also, we have to think while doing our research, that should be utilized for the field, or has to be in mind that it has to be utilized for the field condition. So we have used the products like TMS, and Paralake. So this is the Terra. This is the Terra mesh as a facing material and as a secondary reinforcement. And these are the Paralink material. This is this they have used as a soil main reinforcement. So this project, they have utilized. They have gone up to a height of 80 meters height, flexible retaining wall. So massive wall. So that's what I have told you earlier. Even India, we have up to height of 80 meter. Even you can see the project location. It's a hill location, and so in order to boost the tourism in Sikkim, so it's a part of Sikkim, which is a Himalayan region. So you can think of the variations in the soil profile there, and there is a area of 30 meter wide and 1.7 kilometer length. Need to excavate 100 meter high excavation works. So why? Because the new construction is has to be done in this area, so which is situated 33 kilometer from the capital. So this area is like this. It's in Himalayas, and most of the rock are a soft schist rock. So we need to taken care the shear strength aspects, and it's a high rainfall region also. So we need to have a very great challenge in this. This is the runway which we need to design in the north-south direction, but hill is having a natural slope in the west-east direction. So we have a challenge even for the drainage of water during the monsoon season, and also we may have a cut in this region, so that and also a fill in this region. So that can be easily recognized from this picture. So we need to cut this area and we need to fill this area. So that is the major challenge. So this is the cutting portion and this is the filling portion. So what they have decided that they can use this cut material to fill this uh, uh, fill this portion for maintaining the level. So that is one of the sustainable solution they have made, like the CLSM project which I have mentioned earlier. Here also they have utilized completely the excavated material for filling the reservoir. So that is one of the sustainable solution they have made.
Shobna? Shobna, what happened, Shobna?
Ma'am, in between, ma'am has left, ma'am. I'm calling her, ma'am. I'll
Sorry for the inconvenience. Ma'am will join shortly. Due to the network issue, her network has been ended.
Okay, sorry for the interruption. I think there is some network problem in my area. So I'll just present now. I think it's now audible now, right?
Yes, ma'am. Yes, ma'am.
Okay. I was just talking about the construction of airport at Sikkim. Um, so they have utilized their research team to get an idea about the sustainable considerations for making this airport. They have designed up to 70 to 80-meter height MSC wall and drainage aspects also. So I have just shown here the chimney drain construction, which is in progress for the drainage purpose, and these are the pipes which can collect the drained water from here to here. So we need to follow a complete drainage system for making this effective functioning of this RS wall. So different drainage capturing system. This is one of the beautiful idea they got. So if the water flows here, it is view of this. Coir mat. A certain height of great cost saving. So around 5 to 15% compared to conventional monotype reinforcement system. So they have adapted a combined reinforcement system like Terramesh and Paraweb. So it's a kind of a combined solution so that they can adapt. They can get a cost benefit out of it, and they have utilized the excavated material for a filling also. So that is also one of the sustainable solution. And
Ma'am,
We couldn't hear your voice properly.
ma'am.
They have efficiently the more can plan to get a sustainable
Ma'am,
solution to
your
the means
voice
that
is
in
not
rate
clear.
and in systems they follow recovery and IGBC. So I'm sorry again. There is a network problem.
Now we can hear
Okay.
you, ma'am.
So it's a last 5 to 10 minutes only. I think I can share my window. So I was just talking about the summary, and for everything we need some reward, right? So for that, there are some green rating systems, even for buildings and structures. These are the different green rating system we are following in our India. So the Griha and LEED and IGBC are the three different rating system which are followed in India. LEED is of course US based, and there are different categories like sustainability of the site and water efficiency, energy and atmosphere, and materials. So in that we can include the recycle and reusable materials for our use, indoor air quality, environmental quality, and innovation and design process. So far, actually, it is the data in 2019. So far in Maharashtra, 334 LEED certified projects were there. So Tamil Nadu is in third place. Anyway, we need to boost up this in order to get a mind that we need to develop the sustainability in our day-to-day buildings or any other activities. So IGBC also focused on all these aspects like water conservation, consumer waste, how we are handling the consumer waste, energy efficiency, reduced use of fossil fuels, like we can utilize the waste materials, reduced dependency on virgin materials, so we can utilize the recyclable, reusable materials, health and well-being of occupants. All the under all these categories, we have some points. And so this is the final closing comments. In every aspect of our life, day-to-day life, we need to introduce the sustainability aspect. So as a geotechnical engineer or a civil engineer, we are challenged to do the right project in to do it right, incorporating some sustainability aspect. So sustainability assessment tools, we can use some of the tools, and it can be used to assess or optimize the sustainability in geotechnical engineering. So these examples and case studies demonstrate how the sustainability can be incorporated in geotechnical designs. So I think I can just stop it here. If you have any doubt, I can address. We can share the thoughts. These are the references which I made for preparing this PPT. And most of the references I have given in the slides itself for most of the papers. But beyond that, I have referred these things.
Thank you, ma'am.
Thank you.
Thank you for the wonderful session, ma'am.
Thank you, ma'am. Thank you for the opportunity.
Participants, if you have any queries, you can please post it through chat box.
Actually, since it is an FDP program, that too in the research aspect, I just wanted to highlight few things. We need to write some kind of proposals, so research proposals. Though we are getting or not, that is the second part. We have to try and try and try, then only we can get very few things to be done. So first of all, we need to think of the research base. That is, we have to study a lot regarding the literatures, especially with regard to the research. If you focused, if you want to get to focus any area, first of all you need to read a lot. So that's what I do. So we need to read a lot and get a idea, and in that idea we have to focus more and more, and arrive our own novelty in that idea, and we can frame our research in terms of proposal. So if you want, I just can share my proposal, which I have submitted and got from CRB. Shall I, ma'am? 5 more minutes.
Yes, ma'am.
Yes,
Sure.
ma'am. Okay. Yeah. I think this you can able to see. This is the what it's automatically generated thing from the web portal of SCRB, Science and Engineering Research Board. It's one of the autonomy body of DST. So this is my topic of research. Actually, what I heard from, or I learned from different experts, that we need to specify that we have to be used some of the recycled or reusable material, and which location we can use that one. That also, if you could specify, that will be a better thing. And these are the details of mine, and especially the project summary. They will look upon this project summary, so we have to specifically tell why we need to do this project. So that research gap should be identified and should be mentioned. And there are keywords and objectives. Objectives, of course, should be in bulletin, around 5 to 6 objectives. So why we need, what the aim could be splitted upon with the objectives. And expected output. So they have asked for expected output and outcome. So both of the things, mostly it is same thing, but output means what is the output from the research. Outcome means with that output, what we can do for the society or how we can implement that one. So that is the outcome. And origin of the proposal. This is OTD, that implies the origin of the proposal. So for that, you need to study a lot how we get that idea. So that we need to narrate, and international and national status. So that is purely of literature study. So how it has been followed. So each and everything you need to specify. We should not miss any major literature which is pertaining to this study. So for that we have to study a lot. And importance in the current status. So what is the research gap that you need to specify. If the project is location specific, so I have given as Ananagar as a area, Chennai area. So why we have chosen that area as our project specific location, that we need to justify. And work plan, that is the methodology, how we can do this, if it is a laboratory or even if it is a numerical work, how we can do this, that we have to specify very clearly by giving some of the pictures or any supporting documents. If it is previously done by you, some of the experiments, that also you can include. And time schedule, just I have given like this. You can use better softwares for giving this milestone. And suggested plan of action of the research outcome, so that we can use. And environmental impact assessment. So mostly if we are using the industrial waste, the environmental impact will be a positive impact, so that we can stress here. And the other things, the expertise of the PI and publications and reference. And finally, the budget. So budget you have to specify very clearly. For each and every item we need to specify, especially it is a early career research award. We cannot go beyond, we cannot quote more for the equipment. So I have just quoted around 4,70,000 for just making that modified consolidation apparatus and for some other shrinkage apparatus. So the equipment is lesser. Major cost I have used for the manpower, and I have produced one PhD from this. So similarly, you can try by reading so many literature, and try out a proposal which is more relevant to the current status. So I just want to share with you. It's one of very preliminary work that I have done. Still I'm trying with a different proposal, but yet to get some funding. So it's a trial process only. So if we have anything to discuss, we can discuss.
Thank you so much, ma'am, for spending your valuable time and providing us the wonderful information.
Thank you. Thank you, ma'am.
Thank you.
Thank you
Thank
for
you, ma'am.
this
Thank you
opportunity.
for the thank you for your acceptance and the presentation, ma'am.
Okay, ma'am. Thank you.
We had a wonderful session. Thank you, ma'am.
Thank you, ma'am. Shall I leave, ma'am?
Yes, ma'am. Thank you. Yes, ma'am.
Okay. So if you have any queries, you can contact me also. This is my mail ID, Soundara@Dikshati. Thank you so much for your patient listening. Actually, the 100 count is there still now. That's what I'm just wondering. Thank you.